want to go over the homework from primes and GCDs, but mostly actually GCDs. And first one is 26, asks actually to use the numbers in what is this for a weird thing? I don't know what that was. These are the numbers that already, this is in 24. You have the number 3 cube, 5 to the 5th, and 2 to the 5th, 3 to the 3rd, and 5 square. And if I ask us the least common multiple, and it's the opposite of what we have to do. Let me therefore also do the GCD. I know this is number 24, but just to contrast the two techniques. So for the least common multiple, we look for the highest power. So the highest power of 2 in these two is the 5. The highest power in 3 is the same, so it's 3/3, and the highest power is 5/5. Whereas in the GCD, you would take instead the lowest power. So 2 square, 3 to the 3rd, and 5 square. Okay? And okay, I'm not going to do too many because I mean it's always the same. 2 times 3 times 5 times 7 times 11 times 13, and 2 to the power 11 times 3 to the power 9 times 11 times 17 to the power 4. Let me see that I didn't. Yeah, I think I copied it right. So the LCM. Well, what's the highest power of 2? 11 is the highest power of 2. Highest power of 3 is 3 to the 9th. What's the higher power of 5? Now, just don't get misled by the fact that, oh, there's no 5 here, so it doesn't play. No. The highest power is 5. There is a 5 there. Same for 7. 11 is the same in both, and then 13 is there in the left number, not in the right number, but it's the highest power is there for 13. And the highest power of 17 is 17 to the 4th. So this is the prime factorization of the LCM. And the GCD you can do as well. I want to perhaps do E, that might have thrown you off a little bit, 0 and 5. I just want to solve it because you otherwise might get a bit weird by it, but it's kind of, okay. Any number divides 0, so what is the greatest common divisor between 0 and 5? So the GCD would therefore be 5. That might be a little bit contradictory to the fact you have to take the highest power occurring. Now, you can write 0 as 0 times 5. It's not true. 0 is just a weird number that doesn't really apply well in this setup. So what is the least common multiple then? So nothing is, what is a multiple of 0? Well, 2 times 0, 3 times 0, it's always 0, right? So what's the least one? Well, 0, right? It's 0. So, and 0 is also a multiple of 5. You might say, well, what is that what you're saying? How is 0 a multiple of 5? Well, 5 times 0 is 0. So it's a curiosity. That's not something that we're ever going to have to deal with, but it's just good that you see how it works. Now, a little bit more challenging is the question, the other question was number 40, right? That's a little bit more work, so let's spend a little bit more time on this one. And in 40, now I'm not going to do, I'm doing, let me do the last 5. Let's start with E. I'm taking a little bit of so the GCD of 101 and 203. Okay, let's start with that. And it's not just that. We have to write this number as a linear combination of these two. Okay, let me show you how I do this. I actually didn't in the video, I did with all this coloring, but let me now do just with the circling part, right? So we take the biggest one, and how many times can the smaller one go in there? Twice, right? That is 202, and what you have left is 1. Now, we know that once you hit 1, you're done, right? Because what you need to do, so this is 203, this is 211, these are the two numbers we need. Now we use these two numbers, this pair, 101 and 1. Now, 101 goes 101 times in 1, and then you get a 0. So this tells me already that this is the GCD. I've mentioned this. When we have 1, we know that must be the GCD, when our remainder becomes 1. So we know that the GCD is 1 here. And then how you write it, well, it's already written here, right? It is 203 minus 2 times 101. So this is really not anything special. So let's do a little bit harder number. F. So what's the GCD of 124 and 323? Okay, so 323 is, how many times does 124 in there? So we take these, I'll keep circling each time the number that I'm using in the division algorithm as well as in the rewriting, the second part. Okay, so how many times does I go in there? I have to use my calculator, twice, right? Twice. And that is 248. So what is outstanding is 5, that would be 53, then a 7, 75, I think, right? Let's double check. Yeah, 75. Okay. So we can dispel with this one. That's our first division. But we still have, this is not 1, or not actually not 0, but we know that we can also stop at 1. So we continue. We put the second of the circled numbers and use now the third of the circled numbers. How many times does this is a 1, so it's a very weird 1, but it is supposed to be a 1. 124. So how many times does that go in there? Well, 1 time only, and so we have what is left, 49, right? Okay, 49. So that's our next one. So now we use 75 and 49. How many times does that go in there? Well, 1 time. And then we have left 26, right? Let me just double check. 60, 75, yeah. Okay, I don't want to make a mistake. So we now use these two pairs, 49 and 26. How many times does 26 go in 49? Twice. No, not twice, just once. Okay, so what is left then? 23. Okay, now we use 26 and 23. How many times does that? That's only once. I'm going to write this one. It's a bit silly, but it's good that you see that these circled numbers have coefficient in front of them. These guys, not these guys, not these guys. Notice, okay? Okay, so what's the remainder? 3. So now we use 23 and 3. How many times does that go in there? 7 times. So now you see a real coefficient appearing. That's 21, so plus 2. And then we use 3 and 2. And then this goes there 1 times plus 1. And when we get this 1, we know that's the GCD. So we have calculated the GCD. So that is done. But how to now rewrite the GCD in terms of the original guy? The original two numbers. As a linear combination of the original two numbers. Okay, I'm going to need a little bit of space, so I'm going to move this a little bit. No, I need to go a little bit higher. Okay, let me here. Where is this? Okay, whatever. Then, oh, it moves it anyway. Okay. So, all right. So now we have to work our way back. Okay, and how does it go? Well, we start with this 1. We use this last equation here. Of course, I know there's actually here 2 is equal to 2 times 1 plus 0, and this is where it really stops, but with 1 we know that we can stop already, so let me not dwell too much on it. And this tells me already that 1, I'll box the 1, because it's a bit different than the others, guys. It's 3 minus 1 times 2. Okay, nothing to be done, so I use now the smallest of the circled numbers, replace that using this equation, or rather bringing the other guy to the other side. So this is this gives me 3 minus 1 times, and then 2 is equal to 23 circled minus 7 times 3 circled. Okay, good. I combine, and there's always 2 steps, right? This is the first step, and the second step is combining the circled number. So 3 and minus 7, that is 8. So we have 8 times 3 minus 1 times 23. Let me emphasize, where does this 8 come from? We have this minus 1 times minus 7. Right? So if you want to do an extra step here, I'll do the extra step here. I'll write it here and then. So we have 3, and let's expand the minus 1. Minus 1 times 23, and minus plus 7 times 3. And now I treat 3 as, I treat 3 as a like term, so I say I combine these two things. Of course, it's weird that we do this with numbers, right? Because they're just numbers. You've never done this with numbers, but they play a different role. This 3 is something that is fixed by my calculation, right? These are these various remainders that I get. These are approximations of our GCD. Okay, so I combine these, that becomes the 8, and then this is just 1. Okay, that's where this comes from. Okay, let's go back to where we were. Okay, so we now can use this line, and in particular the 3 there. We're going to replace 8, and then this 3 becomes 26 circled minus, I'm going to be a little bit lazy now and not write 1 anymore. We have seen now how it works, right? Minus. I have replaced this 3, right, by this, but I still have to copy this one. So minus 23, okay? We have now the 23 circles, so we should combine them. So that is 8 times 26, and I have a minus 8, minus 1, minus 9 times 23, okay? Then we go this one, 23 can be replaced, so 8 26 minus 9 times, and 23 is 49 minus 26. And it's very important that I keep circling these numbers, that I know which one have, why I need to circle this? Because I need to know that these are the two that I need to combine, okay? So that is 8, and minus is 9, so altogether 17 times 26 circled, minus 9 times 49 circled. Okay, so now this 26. I'm going to use this one, so that is 17 times 75 circled, minus 49 circled, and then minus, I just copy the second term, 49, and then I combine these 49s, it is 17 times 75 circled. I have a 17 times a minus, so minus 17 minus 9, that is minus 26, right? Minus 26, 49, okay. That's done this, so I can use this one now. This is equal to 17 times 75 circled, minus 26 times, and then 49 is actually 124 circled, minus 75 circled. So if I combine this, is we have a 17 there, and we have minus 26 times minus, so it's plus 26. That is 43 times 75 circled, minus 26 times 124 circled. Notice that these numbers are getting rather big, right? And so I'm not done yet. So now I place it 75 by 43 times 323 circled, minus twice 124 circled. Don't forget there's the coefficient 2 there. We had for a long time only once, but now we have a 2 here. So minus 26 times 124. Again, don't forget your second term here, right? This is the one that we replaced here. And then this is the one that we just copied. And the final answer, we are going to be there, right? So this is, I'm going to write it down here. We know it's 1, but it's also, on the other hand, if I, it's 43 times 323, minus 2 minus 20, no, not minus 2. Minus 2 minus 26, so minus 28. Very, very careful. There's a 43 in front here. So it's minus 86, right? Minus 26, that is 112. So minus 112 times 124. Now let's double check that is what I'm right. I'm done, right? Because these are the original two numbers. Let's work out what these are. 43 times 323. So it's only now. See, that's the circling prevents me from expanding numbers that I cannot expand. I don't want to expand these products here. Now, at the very end, I'm just checking my work and see that this product minus this product is indeed what I claim to be 1. So this turns out to be, according to my calculator, 13,889. And this, so this is 112 times 1, what is this number? 24. I cannot even read my own. This is 13,888. Yeah, the difference is 1. But there's absolutely no way you could have guessed these numbers. By the way, these two numbers that you get are not unique. I told you this, but they are going to be they're going to be the smallest possible ones in absolute value, because one is negative, one is positive always. Okay. I don't know which one you want. Well, there's nobody here to tell me what I should do, so I'm gonna pick another one here. What was I doing? 40, and what I just did was F, right? Yeah, okay. Let me take one of the bigger ones. Big numbers not necessarily means that there's much more work to do, but let's do it. So I'm going to do I. So we do the GCD of 10,001 and 13,422. Okay, first of all, what is it and how you write it? 13,422 is the bigger one. I'm gonna 10,001, it goes in there once, right? And what is left is 3,421. Okay, so now I use these two numbers. I don't think it goes there. It only goes there twice. But I need my calculator. These are big numbers, so I better check all my calculations here. So 3,421 times 2, that is 3,421 times 2 is 6,842, and what is, if I subtract that from 10,001, I get 3,159. Okay, so these two numbers now become my new pair that I'm going to work with. I have to be very careful. People watch me because I'm very bad with numbers, believe it or not. I always write numbers in the wrong order. Okay, so this goes there in once, and what is left is, okay, 3,421, 226. 262, sorry, 262. Okay, so I use this pair now, 3,159 and 262. So how many times is that? 3,159 divided by 262, that is 12. Plus, so 262 times 12 is 3,144. And what is left is 15. 15, 15, 15. Right? Yeah, okay. So my new pair is 262 and 15. We like these numbers that get small, and as quicker they go small, the least number of steps we have to do. Okay, but you see, the number of steps can be. In the very first one is only one step, but in the other one it was way more steps. And although these numbers are bigger, I will see whether we have how many steps we need for this one. 262 divided by 15. It goes in there 17 times. So it's 17 is that. So 17 times 15, that is 255. So what is left is 7, right? Yep, okay. So 15 goes 2 times divided by 7 is twice plus 1. Again we get 1. No, why not? And in fact, you might say, oh, this is really a bit special, this one. Why we do this one? When we will use this method, it will be exactly in the case when the GCD is 1. That is something that is going to be very important for us. You will see in the next 1 or 2 lectures, and a couple of times we'll use this. Okay, so this is what we have. Again, so we know that the GCD is 1. I have to write it as a linear combination. Get myself a little bit more space here. Okay, so all right. I work myself upwards. So I start from this line. It says that 1. Remember, because it's 1, I know I can stop. Otherwise, you have to do one more step, right? But now we know we stop. It's 2 times circle 7. No. It's the other way around, people. It's 15 circled minus 2 times 7 circled. Okay. Now we replace 7 circled. So I'll do a little bit with colors now. But this color is now this replaces that. But of course, this what I mean is by bringing this to the other side. Okay. So this is 15 circled minus 2 times, and that if I bring that to the other side, that is 262 circled minus 17 15 circled. Okay, so let's bring this to the other side. That's this minus. Now we have two 15s circled, so they are combined in like terms. That will be 34, then, yeah, 34 plus 1 is 35 times 15. Notice that all of a sudden we get bigger numbers already. Okay, that's that. Okay, so we're done with this. The next one is 15, so I'll color it one more time that you... It's this 15 and this 15 that I now look at. So this is 35 times. You could say, but why not use this 15 in this 15? That's why I'm saying you have to be very, very patient, or this 15 in this 15. You have to do it step by step. If you skip even one step, your numbers do not match anymore. You're going to all of a sudden find numbers that you say, but how can I replace them? I don't have anything anymore. So be very systematic in this thing. That's the only thing that can go wrong. If you're not, well, two things. Not systematic, and of course, calculation errors. The second one is really not that important for me. It's the first one that I will pay quite a lot of attention to. So that 15 can be replaced by 3159 minus 12 times 262. Okay, and then we have still the minus 260. Also, something you should not forget is there always the second term that you don't replace yet, right? Because it's not our time yet to use this one. It's our time to use this one. That's why I'm not replacing this one. It is true, this is there, and eventually I'm going to replace this. But see, if I replace it now, it's too soon because it's these two combined, and then I will replace it. That's the whole point. Okay, so where are we? So we have 35, 3159, and expanding the 35 times 12, okay, that's already a big number. That is 420, and then that's minus 420, minus 2, so minus 422, 262 circled. Now it's time, so I'll do the coloring again. It's this one that I use to replace this one. Okay? So that is, so this is, I'm getting a little bit out of sync here because, yeah, I don't. So it's 35 times 3159 circled, 422, and then this is 3421 circled minus 3159 circled. Okay, so if I combine these guys, that is 35 times 3159. Oh, no, there's another one there. And that is plus, minus is plus. So 35 plus 422 is 457. Sorry, right? So there's a 35 here and there's a 42 with the plus sign. There's all together. This is the coefficient of 3159, right? Thinking of 3159 as like terms. So that is, did I say 457, 3159 minus 422 times 3421 circled. Okay. Oh yeah, this is the next one. See, that's, you have to keep track because I was already eyeing this one and say, I'm gonna plug that in. No, this one first. Right? It's always the smallest one that you're gonna replace, and that's gonna. So it's you're going back up the stairs, right? And that's why you have to go. You came down the stairs from the biggest to the next biggest to the next biggest to the next biggest to the next biggest. Now you have to go up the same way. Just think of it that way. Okay, so where were we? So I'm going to use this one. I'll do the coloring so that you see exactly. So this one is this one. Okay, so it's 400. It's 457 times. That's 10,001 circled. Minus 2 times 3421 circled. Minus 422 times 3421 circled. Okay, so I'm getting a little bit out of space here, so I'm going to move myself down here. Okay, so what is this? This is, okay, 475 times this guy. And now, how many times do I have the other, this guy? 3421. Well, I have it minus 422 times. So let me write it up now because the number gets so big that you see where it comes from. So it is Let's write a plus here. I don't know what I know it's going to be negative, but just so they see. It's minus 2 times 457. It's a bit late, so I don't want to make any mistakes. That is minus 914. And the other coefficient is minus 422. So if I combine that, so 914 and 422, that is 1336. Okay, so this is minus 1336. Okay, and this is this done. So now finally I can use that one, and then I will be done. Right, it's the last line that tells me I'm there. So this guy I now replace the smallest of the two circled numbers, and so I have 475 times this guy minus 11336. That guy, but that guy is actually 13422 circled minus 10,001 circled. And if I now make the combinations, I have a 457 here and a minus 136, so that is, okay, I'm not going to do this by plus 457, so it is 1793 times 10,001 minus 1336 times 13,422. It's a enormous big numbers to write one. One is equal to these two numbers. But believe me, this is something we will need later. We need to know how to do this. Okay, so it's not a silly way of writing one, at least for this problem perhaps it is, but so I actually kind of a little bit worried that I cannot check this with my calculator anymore, so I'll do it for you because the numbers are already so big. Okay, the calculator accepts it, and this number is 1793. Yes, of course, I should have seen that. So this is 1793. What is this number? It should be 1792. Is it? 1236 times 13422 1792. 1792. It's exactly what it should be. But you see, these numbers get really big. And it's not that the original numbers are extremely big. They are 5-digit numbers. And you see these coefficients are kind of in the same order of magnitude. And when we use these things in cryptography, we normally deal with numbers of size 10 or even 100 digits. So these become, whereas these two numbers and all the numbers involved in between, you notice that all these numbers are never going to be bigger than any of the original numbers, right? Because everything gets always smaller. These are quotients, so they're always smaller, and these are always numbers getting smaller and smaller. So if you start with numbers of a certain size, say 10 digits, in this calculation, the only numbers will have also 10 digits or less. However, in this calculation, because we keep adding these numbers, right? This is actually what happens, right? We're taking all these combinations, and this is where these coefficients get really big, and they could be as big as the original number, so also 10 digits. But then you have a 10-digit number times a 10-digit number, that's a 20-digit number. So is something that cannot be verified anymore. Calculators normally have 10 digits about or something that they can show, unless you have a bit of a special calculator. Okay, I know that this is not everything from 40, but I think I did kind of one of the more important ones. I'll do also a separate review video because I'm going to quiz you on exactly this. Okay, so I perhaps just use another example from the textbook. Okay.